Professor, what is the gain of this PFC converter? Could it do both step up and step down?
Say it again.
What is the gain of this PFC converter? Could it do both step down and step up?
Well, first of all, the transformer is capable of step up and step down, right? So you can do the two things. You can use a transformer in a step with the turns ratio to step down. In addition, if you are most of these converters I showed today, they have isolation transformer. One is a step down by definition from inputs to output. Like the second one I showed you, it was one which is a DC input and using transformer to step down and output backstage, which steps down to duty ratio and step down in addition to the transformer. Now, the boost version, which I showed you for AC to DC charger, it is capable of, and that's why we use a boost, because we want to have, why boost is important for power factor correction. When the input line is sinusoidal, voltage goes from 0 to 110 volt, 150 volt peak. What happens, you need a boost to go from, when it's low voltage, to boost it to fixed voltage on the output, and when it's 150 to boost it to same fixed voltage output. So the advantage of the boost is that voltage ratings on the output switch are equal to the output voltage. So you're not anything there. But input voltage is right like a boost because it needs to boost that voltage to this rail when it's going to be fixed voltage. You know. But step down version, so you wouldn't want to use their step down when you already have step up capability, right? And you may use more step ups through transformer. However, general comment I could make is this. I think we are doing in both of this favor by trying to do step down. Let's say in a step down converter, which I showed you, where you can do step down through duty ratio and step down through
turns ratio.
Why I would prefer that you don't do the step down through the duty ratio or minimum, maybe 2 to 1, maybe 3% or whatever, just for the purposes that you regulate, because then duty ratio can help you to regulate.
Right.
Because a transformer in power electronics does one great thing, which does the same thing by default, but not as great as in a 60 hertz transformer. 60 hertz transformer is used also as an impedance matching. So if you use the turns ratio, you can transfer the secondary impedance to primary and with the turns ratio and so on. However, isolation transformer in a power electronics switching converter does one thing which is not present in a 60 hertz, which is the most important. By turns ratio, you are scaling the voltage and current stresses on the input switches to voltage stress current on the secondary side with the turns ratio step down. So that way you automatically balance the voltage stresses. Input side will have a high voltage, low current, and stresses on the switches, and output side will be by turns ratio proportionally scaled to low voltage, high current on the secondary side. Right. And of course, if you do more of this step down to duty ratio, the more of that feature will be lost. So you will not get optimum answer. And to start with, most of this, look at a forward converter. You know why a forward converter? We'll get to it. I'll have a separate lecture on it. But why a forward converter is bad and it started great? It has a AC transformer. Okay, it doesn't. The transformer has to be reset. You have to have a reset circuit. But it has this inductor on the output of the buck. And inductor on the output not only is bad because store energy, but you cannot operate transformer. The way how transformer operates in a forward is bad because you would like to operate it at 90% duty ratio transformer, because then flux on the output inductor will be 10 times smaller. But you cannot do that because of switches, because when you go 10 times higher duty ratio or 90% duty ratio, not turns ratio, but 90% duty ratio on a forward converter, yes, you will have a very small inductor, but that switches on a secondary or two diode on a secondary will be 10 times bigger than the output voltage. Do you want to do that? So you don't want to do that. Okay, so, and then you can go, if we go to a low side on a low input voltage, well, then what is the point? You operate 10% duty ratio of forward converter, and those who ever build and use it, it's 10%. But okay, now you don't have a problem, with the more, voltage rating on the primary side. You don't have a problem on a secondary side. You do have, because of low duty ratio, also you're going to have a much higher voltage on the secondary side than what you're delivering. But the main problem is transformer in forward converter is only transferring the power during on time or main buck switch on the input. So 10% of time is transferring power to the output. And when you have a reset circuit, 90% of the time is doing nothing. It's just resetting it back to zero flux because it doesn't have ability to go to negative flux. You want to make a transformer that it's only 10% of time is transferring power, 90% is doing nothing. I mean, that's not good. You see what happens with true converter? If it is a 50% duty ratio, both for a positive on time and off time, is transferring the power. If it is 10% duty ratio, yes, because it has a bidirectional flow in magnetics, that is transferring power for both. So if you're operating a 10% duty ratio, yeah, you're transferring power to the output, but also for remaining off time, you don't have a reset. You are actually automatically operating such that just like 60 hertz sine wave transfer power to positive negative cycle, this one transfer for positive and negative side or square wave. And the same thing for one Chuk-Bak 2 that showed you, but operates with duty ratio, but it's transfer power all the time. Okay, so. All right, so any more questions? Because what
I have a small question about the main switch in the PFC converter you presented. What about when the switch off due to the leakage, the resonant inductor, you will get anywhere small over voltage? Is there a protection circuit needed or some recovery energy circuit needed?
I don't think so. I don't. We'll go. I'm preparing with one of my assistant, Ben Gonzalez. He's working on making the simulation like he did already for the first online class in September last year. So we'll show you a simulation of when this resonant inductor is included. So it doesn't, the key point is that for the first time, a resonant inductor is switching at times when the current through resonant inductor is zero at the beginning and zero at the end. At each of the switching instances, when it switches from on to off and off to on, it is conducting a zero current. So you're not storing energy, so we don't see that. But anyway, that's a detail that we'll entertain when we have a simulation and going directly into one of these circuits. Okay, but yeah, in the Chuk converter, when we have a square wave voltage, a square wave current, then we basically can use the additional switch to, not reset switch, but just to energy stored in a leakage inductance to return back to this switch, which is to reduce the spike. Which can be, we discussed it. It can be either non-dissipative or dissipative on this base number on that main switch to eliminate any energy stored in a leakage inductor. But that is because it was square wave switching. But then we graduate of that. I don't want to use square wave switching. I want to now use the resonant switching. The resonant inductor is do everything. It doesn't store energy. It makes zero voltage switching on inputs, two switches, and makes the zero current switching on output switches. So everything's there. So what I'm telling you, in general, I said engineers start to get a problem with that. I have some top engineers working for me and with a PhD and so on. And they always felt that the electrical engineering is just as I told you, to fix some problem here and make it worse on the other. No, what I hope that I showed you today, the right invention is to fix all the problems and everything is so much better, right? So that's the ultimate goal, right? Especially because if you're going to make a product out of it, why do you want to make inferior products that you have that you mentioned, you have all the problems in making 50,000 units, right? Because I have the same fundamental problem. You have to solve a problem and then tell people, build this because this is much better, right? And that's why I have a problem with industry in general, because, they have this feeling that it's like disease. If you try to license some technology that is mission that you don't have it, which is true, but then why not participate in advancement of the technology and provide something better to customers? So that's still an unsolved problem to me. Why industry is so ignorant, and I think they're digging a big hole to themselves. Virus, they will survive, but this other plague that they don't want to use better technology eventually will cause many companies to, especially in power electronics, to get in a big trouble. Because the advancement must continue, and unfortunately, what I see is a lot of. I see it in my course. I thought, frankly, I was very excited that I thought when I offered this course that all these big companies will say, we don't have to send them for a week, and we don't have. They are from home working for 2 hours, and they were just flooding it, but they ignore it because they don't want it to be known. That's a problem. That's a problem. They don't want a good message to be carried because they are afraid of what they engineers. Bosses are, managers are afraid they will lose, hold off on the company that they are. A lot of these companies, they have CTOs who are supposed to be the leaders to technically well-versed to advise companies in which direction should have a company go. But most of them don't have a basic training. They're MBAs, business managers, right? And then engineers don't have the power to tell managers what to do. So that's a puzzle which cannot be solved because there's an inherent conflict. That's what it is. Okay, I'm running. I have time for one more questions, and then I got to run to make my appointment. Okay, and I'll send you. I already send you a bunch of these for tomorrow. Okay.
Professor Chuk, that was an impressive thing to see, to take a full offline converter to 48 volt or 24 volt. I have dreams of building I'm only working in the few 100-watt range, but even there we can still take the charger and make it half the size again. And that's got to make it less money and more efficient. That's a good thing.
Okay, very good. I hope the other people agree. Let's see. Show of hands. Yes, no, or
yeah.
maybe.
I want to go build a bench and build one.
Okay, all right. I hope you learned something today, and there is a lot more to learn. As I said, get your friends, get your wives and husband, and join my course. Okay. Very good. All right. Sorry for shortcutting you today, but I had to do this. I couldn't change it. So I will see you tomorrow at 8 o'clock in the morning, and we'll send you some stuff to, as I said, maybe some of this, when we edit it, some of this could be sent to put it publicly. Okay. All right.
So I have a question regarding editing. When you finish your meeting, can we talk about this editing?
Yeah, we can talk after I will be back in half an hour, so we can talk about that. Yeah, we can talk about that. So then, because I decided to, as remember I told you, I go with the course notes, follow the course notes, but at some point, I don't want to follow the course notes and become in the last week or two, and then I have to put you down a lot of stuff to understand in 1 week. And you could say, why didn't you tell us this? So now I'm telling you this along the way, classical things along the way prepared to this, but the more it's going to come with a detailed explanation. And today was more like, if you call this my marketing 2-hour presentation to compete with the APEC courses with the 3-hour courses when they are doing basically marketing. I'm hopefully now standing competitive with all these 20-30 courses APEC with their marketing courses, you know. But mine is having content also, I think. All right. And by the way, I have too much hair. I'm going to go have a haircut today. Okay. So take care.
Thank you. Bye.
Thank you.
Bye.
Bye. Bye.